welcome back. So, this is the 12th lecture in this 20-hour course. So, 20-hour basically mean 40 lectures each of 30 minutes. So, in the last class we briefly discussed in not all the technical details, but the concept of AHP and how it can be utilized to solve a problem where the decision is to buy the car, and it can be expanded for very complicated problems also, and it gives very good results. So, now if you remember in the initial part when we just started, we had completed 3 or 4 lectures, we did discuss about decision trees, and also I am repeating again, we did discuss the methods of how different type of financial concept can be used to make a decision for a project. So, today in this 12th lecture we will consider that how decision analysis can be used. So, what are the salient points of the decision tree analysis? The key steps in decision analysis are as follows. You should identify the problem and the alternatives, delineate the decision tree, that means draw it very clearly where the probabilities are given, the actual values are given, specify the probabilities and the monetary outcomes. So, you have to make a combination of the monetary values and the outcomes and the probabilities, evaluate the various decision alternatives which are there and take a decisions accordingly based on whatever different criteria it is, whether you want to maximize the return, minimize the risk and other different combinations. Remember the decision points also called the decision forks. So, in the initial part when we are discussing, we said decision gates, alternative gates. So, they are something where you on the same line where you make a decision accordingly. They are denoted by D, and the alternative actions are available for experimentations, and actions are possible at these points. So, at a decision point you can either take the right fork, the left fork, or if there are 3 outcomes you can take alternative 1 or decisions 1 or 2 or 3. While the chance points are called the chance forks, where there are chances of one alternative being true or the decision being true, they are denoted by C, and these are the points where the outcomes are dependent on a chance occurrence, and the likely outcomes at these points are a conglomeration of the decisions which are already been taken. Now, when you are trying to proceed for the decision, remember that you would not basically go from the start to the finish, but backwards. Why it is that? I will come to that within few minutes. So, we now discuss a problem before going to the theory. So, we will discuss the problem, because this will give you an idea that how decision and expected values, and later on when we consider different concepts of utility, it will give you a good picture that how it can be utilized. So, we will just consider the problems in a holistic framework where probabilities and values are given. So, now I have shifted from PPT to Word document, because drawing the diagram a little bit complicated with all the decision nodes and all these things was much easier in Word, even though there are other softwares which you can use. So, consider this first set of points which is there we have already discussed. So, I will just start bang on with the problem. The scientists at Spectrum have come up with an electric moped. The firm is ready for pilot production and test marketing. This will cost rupees about 20 million and take 6 months. Management believes that there is a 70% chance that the pilot production and test marketing will be successful. In the case of success, Spectrum can build a plant costing about 150 million rupees. The plant will generate an annual cash flow of 30 millions for 20 years. That means, for a 20-year period you expect that. If the demand is high on an annual basis, a cash flow of 20 millions when the demand is low. So, there are 2 such occurrences. It can be very high, medium and low also. In that case there would be 3 such occurrences, but in this example we take 2. High demand has a probability of 0.6, low demand has a probability of 0.4. So, if there are 3 different type of demand probabilities, remember the sum should always be 1, like here in this case 0.6, 0.4 is 1. In that case, if there are 3 different forks, forks means this one, I am trying to basically consider there, let me go back to the slide, it will be easier for me to make you understand. So, say for example, we have this is one and there are 3 alternatives. So, this probabilities which is given as P 1, P 2, P 3, the sum is 1. In this case it is true because 0.6, 0.4 is 1. So, again let me switch back to the decision tree problem. So, now if you see, if you read the problem, if you note down on a piece of paper, based on that we will slowly proceed and draw the diagram. So, the diagram is like this. Stages of evaluation, if you remember, are the green vertical lines. So, this is say for example, stage 1, stage 2, stage 3, and the decision is like this: either you go or do not go, that means do not do anything. And this 20 which is red in color basically means that you are investing, that means some amount of money is going out of your pocket. And this blue one which is 20 million per year actually means the overall amount of money which is coming in your pocket on a yearly basis, quarterly basis, whatever it is. So, if I consider the problem from the right mode extreme, because what I will try to do is that I try to basically analyze the problem from the end result and slowly go into the actual source where the decision would be made. So, for the extreme right values, 30 million means there is a probability was 60% of high demand and you would get on an annual basis 30 millions as the payback for a 20-year period. In case if the demand was on the lower side, which a probability of 0.4, that means there are 2 arms, then the value would be 20 million per year for again the same duration. So, this 20 year being same for both of them need not be so, it can be different time frames. Now, this is what I called as C22, that means there are 2 now alternatives occurring, there is a chance. Now, this 150 means that you are investing. So, if you read the problem, let me go back to the problem again. Spectrum can build a plant considering 150. So, this 150 is the actual investment, and if I consider this 200, actually this 200 means it will cost and take the test and the pilot production to happen. So, this is basically the concept, the firm is ready to invest. So, this is the 20 million. So, this time frame is 6 months. Now, once it is done, either you go and no go and make a decision accordingly. Now, let us go one by one at C2. So, what you are trying to do, you are trying to find out the expected value of that decision at C2. So, at C2 how many folks are there? There are 2. So, probabilities are 0.6, 0.4. What are the values? 30 million, 20 million per annum. Now, if you see the whole concept inside the bracket, it basically means the time value of money as of now. So, if I consider an interest rate of 12%, which is constant, if you remember the problem in the instances where we were discussing the different type of financial concepts which can be utilized to make a decision, I did mention that the interest rate can either fluctuate, hence you have to take an expected value. Here we are considering the expected value to be 12% for 20-year time period on an annual basis, which is very simplistic, it can change. Now, if I consider these for a 20-year time period for the 30 million which will be paid back to me for a very high demand one, it means that after the first year, if I get that money, what is the present value of that? After the second year, if I get back that money, after 2 years gap, what is the value of that? So, that means 30 multiplied by this term is after 1 year present value, 30 multiplied by the second term is the present value for the second term. Similarly, for the last value to be 30 multiplied by this last term, where the term has in the denominator 1 plus 0.12, which is the interest rate to the power 20, that means for a 20-year time period. So, if I add up all of them, I am able to add up because 30 is a common factor, I take it out. I find out multiplying by 60 percentage of 0.60 is what is the value of that overall 30 million which will be paid back to the firm considering is a high demand. Similarly, I find it for the 40% which is on the lower demand. So, I multiply them, find out the expected value. Now, here just a note, as I mentioned, again I am mentioning 12% may change for both the cases, time frame 2020 may change for both the cases. So, the expected value is 194. Now, if you consider the 194 here, it means that if I conglomerate all the values here, the overall net worth is 124. So, what I will try to consider is that whether 194 is greater than 150, if it is yes, I will invest, if it is no, I will obviously I will not go into that. So, let us go into the next stage. At D2 where you will take a decision, that means in D2 you would either stop or else you will go ahead, that means go ahead and invest 150 to build up that part such that production would be there with the probability of high demand 60%, low demand 40%. So, at D2 you find the expected value at D21 at this point is 44.2, hence as this decision with respect to the other one. So, here what you will do is you will stop the production if it is negative and you would not do anything. So, what you do is that you compare D2 and D3, this is positive, which means you will definitely take that, which is shown here. So, as D21 is greater than D22, hence D2 is selected, 21 is selected. So, these suffixes are based on from which point to which point you are going, the nodes and the arcs, even though it does not have any direct implication with the PERT and CPM, just I wanted to mention that. Now, similarly at the point of C1, so what I will do at C1 is like this 44.2 is already the value which is positive here. So, what I will try to find out is that whether the probability multiplied by 44.2 and the value where I am not taking a decision whether that is positive or negative in the overall expected value cells. Similarly, what I will do is that 70% or 0.7 multiplied by 0.4, I am just skipping the and going up and down the slide, but please bear with me. So, it is 0.7 into 44.2 plus 30% into 0, because why it is 0? Because there is no cost involved. In case if there was a cost involved, if it was negative, so obviously it can be true that 70% into 44.2 plus 30% into a negative value, if that was negative, obviously you will stop. That means even if this value is giving you a positive one, it will definitely mean that here there is no at all any logic in trying to proceed in the later stages. The later stages are the right hand side of the file where the cursor is now hovering about. So, this means I am trying to go from the left to the right and take a decision at each and every step. So, at C1 the value is 30.9. Now, at D1 what I do is that this value I have already found is expected value of 44 into 0.7 plus 0 into 0.3, and then try to compare whether 20, which is the amount of money which is going out of my pocket, is more or less. So, again I find out this value is 30.9, 30.9 is greater than 20, which is 10.9, hence it would actually means I will definitely invest into that project. In case say for example, this value was considered it was 40. So, in that case the value would have been 30.9 minus 40, which would be almost in the tune of minus 10, hence you would not go into that project. So, this was a very simple example. Let us consider and extend this concept for a second example. An oil company, while evaluating the oil basin, is considering few alternatives. Now, you will see that there are 3 alternatives, not 2. So, it is either drill, conduct seismic test with a cost of 20,000 and find the nature of the underlying oil basin, or do nothing. So, doing nothing is also an alternative. So, if the company drills, the oil basin can be of 3 types depending on the geophysical characteristics. Either it can be dry, wet or soaking. Now, if a dry well yields nothing, that means it would not give you any oil. Wet well will provide you moderate quality of oil, and soaking well will definitely give you the maximum amount of oil. So, now what will depend that the underlying oil basin structure can also be of different qualities or variety. One can be no structure, one can be open structure, and one can be closed structure. These are just characteristics of the basin where you will be trying to drill. Now, if no structure is found, then the prospect of finding oil is very bleak, almost 0. If an open structure is found, then finding out the probability of oil is fairly high, and for if the structure is closed, then the prospect of finding oil is very high, that means probability is very high. So, these are the qualitative feel of the problem which is there. Now, with that I will just slowly try to give you on the probability sense how this whole situation makes a sense that you have all the values in the quantitative sense. So, here are the values. Probability. So, P means probability, probability state is dry is 50%, probability is wet is 25%, probability is soaking is 25%. So, if you add up all them it is 1, which it should be as it is. Then I go to the probability of geophysical structure or geological states. No structure 40%, open structure 30%, closed structure 30%, again the sum is 1 as it should be. Also, we have a joint probability or conditional probability based on different type of oil bearing states and geological structure. That means, I am trying to now compare and find out the condition probabilities depending on one has occurred, other may occur or vice versa. So, this is where slowly complications will come, but it will definitely give you a very good idea how the problem can be solved. So, this pink one which you see are the oil bearing states, though they are dry, wet, soaking as I have already mentioned, and if you remember dry was 50%, see the value on the rightmost column, wet was 25%, soaking was 25%. So, these add up to 1. If I consider the underlying geographical structure or geological structure which is in the blue color, there is no structure, open structure, closed structure, closed structure has a probability of 30%, open structure 30%, no structure 40%, again probability is 1. So, the values which you have along the topmost the bottommost row and the rightmost column are the marginal probabilities of the state, considering that the geological and the oil bearing states are very nicely shown. Now, if I want to find out these values which are given inside, they are provided. It means that provided is no structure and dry, the probability which is given is the conditional value is 0.32, or say for example, with soaking and closed it is 0.16 or 16%. So, you will have the different values which are given. Finally, the oil company also has the following set of information, which means the net present value of the dry state is, this is minus value which is negative. Net present value for the positive set is positive 0.8 and for the soaking it is 2.4. So, it is minus 0.5 plus 0.8 plus 2.4. So, if I go and try to basically find out the overall problem, the problem in the diagrammatic sense, in the decision analysis sense looks like this. So, the first I will show you the diagram, which I will try to basically reduce the size of the Word document and try to basically show you at one go rather than going up and down in the Word document. So, let me go first to the diagram. So, let me reduce and zoom in. So, if you zoom in, just concentrate on the diagram as such. So, this is the overall diagram which I have, where I am just moving my cursor. So, it means that these values which are there, dry, wet and soaking, are the structures which I have discussed. So, this is dry, wet, soaking, dry, wet, soaking and so on and so forth. And this minus and plus probabilities have been very nicely shown in color in order for the students to understand. If you remember, I did mention negative 0.6. So, this is 0.6 in the red color, then we mentioned positive 0.8 which is 0.08, 0.8 in the blue color, and then I also mentioned for the soaking part the values returned was plus 2.4 which is again in the blue color. So, these are given for all the states. Now, if it is given for all the states, now let us go through all the arts in little bit detail. It will give you a very good picture how the problem has been formulated. So, if you drill, you have to invest, which is the uppermost part, and if you do not do drill, do not do nothing, this is the arm which is there, which is D13, do nothing. Now, if you drill without considering any test, so immediately you can have either dry, wet and soaking. Now, if you conduct a test for which, if you remember, there was 20,000 cost overlay for that, because that is the cost which you have to incur for doing the test, then doing the test would give you the structure as no structure, which is this arm, open structure, which is the C22 arm, and this value would basically give you the closed structure. So, closed, open and no structure would always lead to the fact whether it is dry, wet or soaking, depending on the first part you consider no drill or no test, and this whole half, this whole 3 sets of decisions which are there, depending on whether you drill or do not drill, considers that you have already conducted a test and found out the properties. So, these are the values which are very shown clearly. This green one are the decision making stage, and as already discussed, the circular part and the D part basically gives you the decision and the chance for forks. Now, again let me go back to the problem and solve it one by one. So, remember, note down these values on a piece of paper, these are the probabilities. Note down the overall problem which is given with the probabilities, and let us slowly solve the problem. So, at C1, which means that is the value which is there for C1 is this part. The probabilities would be, now just I did skip, but let me again come back to this diagram and discuss the probabilities. If you note these probabilities 50%, 25%, 25%, then 4 by 8 which is 80%, 1/10, 1/10, these are the values which are already there. So, either you utilize this matrix which is there considering the marginal values and the conditional values, based on that you have basically written down all the probability values which are there. So, if you consider probability C21 is 4 by 10, if you consider the probability C23 is 3 by 10. So, all these values are considering the fact that you have conducted a test for this one, conducted a test, and then you have found out that there was basically closed structure here which is 3 by 10. Considering you have conducted the test, then it is open structure, that the corresponding probabilities are given. So, all these values are coming from the table which is already provided. So, if you go one step at a time, at C1 there would be 3 values, negative 0.6, positive 0.4, positive 2.4, but they would be multiplied by the corresponding probabilities. What are the probabilities? The probabilities are 50%, 25%, 25%. So, you find a value of 0.5 which is still positive. Now, at C3 again the values of minus 0.6, plus 0.8, 2.4 remain the same as these blue and red values show, but the corresponding probabilities are changing depending on the conditional values. So, now what you have at C3, so let me go through C3 is this portion, it will be minus 0.6 into 4 by 5th, plus 0.8 into 1 by 10, plus 2.4 into 1 by 10 which is given here. So, you find the value of minus 0.16, which means that the value over net value which you have at this point is negative. So, negative with no drill definitely would mean that you would not drill, not take any action. Technically means if there is conducted a seismic test, there is no structure, which means you would never invest in that point. That means, because if it is negative, if you have drilled, the overall value would be negative. Similarly, let us come into this set of arcs and this set of arcs one at a time. At C4 again minus 0.6, 0.8, 2.4. So, 0.8 and 2.4 are positive, and what are the probabilities? Half, 1/3, 1/6. So, let us go. So, these are the probabilities, half, 1/3, 1/6. Again I am repeating these values which are there, the probabilities can be found out from the matrix. Similarly, if I go into this last so called node, it is minus 0.6 into 1 by 10 here where the cursor is, then again plus 0.8 into 11 by 30, and this value of 2.4 into 16 by 30. So, now 16 by 30 actually means that how you are getting is basically you have conducted the test, then you found out that there was basically closed structure, and based on that when you had drilled there was a soaking basin based on which you find out the maximum probability of getting the oil. So, this is 1.5313. So, hence the decision you have to make is that at this point when you are basically this was negative. So, obviously you will not do anything. Now, if I consider this value with no drill, this value with no drill, obviously it will mean that in all the instances they would be corresponding no action, some action, some action. Action means the drill concept which I am saying. So, at D2 it is negative, hence do nothing. At D3 positive drill, D4 positive drill. What are the values? At D2 it was negative, which is so hence compare with 0, it is 0. At D3 it was positive 0.367, hence the value is 0.367. At D4 it is 1.513, hence it is 1.513. Now, if I want to find out the values at this point, what do I have? This whole value is 0, 0 multiplied by the probability 4 by 10, here it is 4 by 10. This arm had a positive value, what was the positive value? 0.367, here it is again 0.367 multiplied by the probability 30% and 1.513 multiplied by 0.564. Hence, again I compare 0.564 and considering this. So, this is 0.564, you had a value already found out here and this was 0. So, you will basically try to compare them and then find out the values accordingly. So, based on the above evaluation, the alternatives can be found out that the set of decision strategies are follows. So, this basically gives you the probabilities and the values in the negative and the positive sense are given in the red and the blue color. So, the expected value if I find out. So, if you follow up any arm D12, C21, D22, the probabilities are given from the tables which you can find out and the net present values which are already there. So, once the net present values have already been found out considering the calculations which you have already done, the expected value can be found out as 544,000, that means positive, and in case if you want to find out the variance, you can use the simple concept of the variance to try out the value as given in the formula. So, we can make our own decisions according to the concept where we want to maximize the return as highlighted, minimize the risk or make a balance between them where you take basically a ratio of trying to maximize return to risk or minimize risk to return or different type of multi-criteria decisions can be made in order to make the decision. So, these two problems which I discussed, one was there was no conditional probabilities, in the second case there was conditional probabilities with the simple values and the concept of net present value was also there. So, in the assignments we will also try to tackle such simple problems and the assignment solutions will already be, which will also be provided to the students to understand both the concept of decision trees, which is the second set of problems we did, as well as in the concept of AHP in order to make you understand how these two different techniques are used in a very big way. Have a nice day. Thank you very much.